is when the objects move from one position to another, from one place to another place. Okay, who can tell me some examples on objects which are in a motion state? For example, train. When the train moves,
Metro.
it's in a motion state. Excellent. Also metro. Excellent. What else?
Car.
Car. Excellent. Soda. Perfect. Okay, someone else tell me. Any other example for object which is in a motion?
Airplanes.
What?
Train.
Train. Excellent. Who said train?
Bus. Anas.
Excellent, Anas. Excellent, Ronza. Excellent. So we have, what else?
Spring.
The spring.
Yeah.
Okay, when it moves, okay, it makes motion. We can consider it, okay.
Swing.
So we say train, car, bus, airplane, even a human. When a man move, when a man walk, this also, the man is in a motion state. So any object that move from one place to another place, this is called motion. So we can see many objects around us that move in different directions and at different speed. A car can move slow, a bus can move very fast, or a train. Both of them are in motion state. One is slow, one is fast. It doesn't matter.
Yeah.
Okay, so we can say that the motion, it is the change of an object, location, the location or the position of an object as time passes according to the position of another object. What does this definition mean? Okay, here we have location, time. What does that mean?
Can you repeat, teacher, please?
I want you to see this part of video. I'm asking a question. In the motion definition, it's written location. The object move from its location or from its position as the time passes. We are talking about location and about time. I want you to look here.
In our earlier grades, we have studied motion and its types. Let's have a quick review. Let's start with motion. In simple words, if a body is moving, it's described as motion. That's all. In slightly more technical words, motion is defined as a change in the position of a body with time. Yes, change in the position with time.
So what is motion? Change in position?
Change in the position with time.
With time. So if we want to talk about motion, we are going to talk about two things. The change in position and
Time.
Time. Excellent.
For example, when an object is moving from point A to point B, it's changing its position with time. We saw that the time is also changing along with the position. So it is undergoing motion.
So here the ball. The ball was standing at flag number A. Then it moves till it reaches B. So here there is a change in position. The position of the ball changed with time. It moves in how much time?
9 seconds.
9 seconds. Excellent.
What are the types of motion that we had studied previously? We have seen 4 types of motion.
We don't want the types now. So now we understand that the motion, it is the change of position with the time. Who can tell me what is motion?
The change of position with time.
Excellent. Anas, can you tell me?
It is the change.
Yes, the change of.
The change of an object position
Yes.
as time
What?
passes according to the position of another object.
Okay, excellent, Anas. Perfect. Who else can tell me? Myrna?
Yes, teacher.
Tell me, Myrna, what is motion?
It is the change of an object position, location as time passes according to the objects in front of it or according to the speed.
Okay. Thank you, Myrna. Thank you so much. Excellent. So here, to simplify the concept of motion, we will only study the motion in one direction. Okay, when the car moves, it moves from one direction. Or as we see in the video, the ball moves from A to B. It moves in one direction.
Yes.
Whether the path of a moving object, it can be straight or curved or combination of both. How? For example, if we have here a ball, the ball can move like this in a straight line, right?
Yes.
Or it can move like this. What we have here, it
Curved.
starts moving in a straight line, then curve. Or it can be moving like this in a curve. So a straight line or curve or both of them, combination of both. First, it can move like straight line, then it make a curve. So the motion of any object can be in three ways: straight, curved, or combination of both. Who can tell me the three ways of motion?
Me.
Come on, and
Or curved or combination of both.
excellent, Anas, excellent. Sarah, can you tell me?
Straight, curved, or combination of both.
Excellent, perfect. Thank you so much. Okay, but the simplest type of motion, the simple type of motion is the straight line. When an object moves in a straight line in one direction, which means it goes from here to here and doesn't go back, this is the simplest type of motion. A straight line and in one direction. Is that easy for all of you?
Yes.
Yes.
Yeah.
So now we talk about motion and we understand all of the examples of moving object, and we took the ways in a straight or curved or combination, and we know that the motion is a change of position within time. Okay, how else can we describe this motion? As we said, the train, the motion of the train is fast or slow?
Train. Fast.
Fast, okay. What about a bicycle?
Slow.
Slow. So we can say that the motion can be described by something called speed, right?
Right.
So any motion has a speed. This speed may be fast or maybe slow. So we can describe the motion as fast or slow by something called speed. So the speed is a physical quantity which is used to describe and compare motion. How compare motion? As we said, if we compare the speed of a train or the motion of a train and a bicycle, we will find that the speed of motion for the train is faster. Okay, let's see another video for the speed.
How do we know whether an object in motion is traveling faster or slower than another object? Consider two objects, Object 1 and Object 2, both moving along the same path. Just by looking at their motion, can you tell me which one of them is moving faster? Clearly, this one.
Can you tell me which one is moving faster, Object 1 or Object 2?
Object 1.
Object 1.
Object 1, excellent. Because they start at the same point here, but within the time, Object 1 is further than Object 2, so it is faster. So Object 1 has high speed or low speed?
High speed.
High speed.
Perfect, excellent.
One is moving faster. In comparison to Object 1, Object 2 keeps lagging behind. Hence, we say that the speed of Object 1 is more than the speed of Object 2. Speed is that physical quantity which tells us how fast something is moving. How do we define it? In order to know the speed of an object, there are just two things we need to know. First, the distance traveled by an object in motion, and second, the time it takes to complete that distance. Consider a car moving on a straight road. First of all, can you tell the type of motion it's object in motion? And second, the time it takes to.
So here, to talk about speed or to determine the speed of an object, we have to know two things. What are they?
Distance and time.
Excellent. Distance and time. The distance that the object moves and the time it takes to move from one position to another. For example, the car moves from point A to point B in 2 seconds. So the distance between A and B, I have it, and the time, which is 2 seconds. From the distance and from the time, I can get the speed.
Complete that distance. Consider a car moving on a straight road. First of all, can you tell the type of motion it's undergoing? Since it's moving in a straight line, it's in a rectilinear motion. Suppose the time it takes to reach the other side is 30 seconds. Now consider another car which is similar to the first one. It's also moving in a straight line path adjacent to the first one. The time taken by this red car to cover the same length of the road is 40 seconds. The blue car covered the path length.
Okay, now I have a question here. The blue car and the red car, they start from the beginning and they move till they reach the end. But the blue car take how many seconds?
50.
And the red one?
40.
40.
Okay, which one has higher speed?
The blue one.
The blue one, excellent, perfect. Because the blue one move the same distance, but in more time or less time?
Can you repeat again?
Why the blue car has higher speed? Because it moves the same distance, but the time is high or low?
Low.
Low.
Lower time, less time, excellent. So here we considered the distance and we considered the time. When the object takes less time, that means it has higher speed.
In 30 seconds, while the red car covered the same path length in 40 seconds. Which one of them was moving with greater speed? By intuition, we can say that the blue-colored car was traveling at a greater speed than the red one. Why? Because the blue car covered the same distance in lesser time. Let the length of this path be 420 meters. This path length is nothing but the distance that the car travels in a given amount of time. Now for each object, if we take the ratio of the total distance covered and the time required to cover that distance, we will get this. This ratio is called the speed of the object. Yes, speed is distance over time. Since
Okay, so if we want to calculate the speed, we will make the distance over time. If we want to calculate the speed, we will do what?
Distance over
time.
Distance over time, the distance moved by the object over the time taken. Here, this is the same one. Two cars moving. The yellow car take 5 seconds, while the red car.
And the red car take 10 seconds.
Yes, which one is faster?
Yellow car.
The yellow car, excellent. But the yellow car is faster than the red car because it takes shorter time than the red car to cover the same distance. We have to be sure that the distance is the same. Both of them move 100 meters.
Yeah.
Here is another example. The two cars, each one moves for 5 seconds. Here 5 seconds and here 5 seconds. But the yellow car in 5 seconds, it moves 100 meters. But the red car move only what?
50 meters in 5 seconds.
50 meters in 5 seconds. So which one is faster?
Yellow car.
Yellow car, perfect. So the yellow car is faster than the red one because it covers longer distance at the same time. So here we can conclude that to get the speed, we have to deal with two things: distance and
time.
Excellent. Here we have distance and time. So here is the speed. Its symbol is V. If we want to get it, we will make the distance over time.
Yes.
Okay, so Anas, how can I calculate the speed?
I can calculate the speed by distance divided time.
Distance divided time, excellent. Malak, tell me Malak, how can I calculate the speed?
Teacher, can I say it?
Okay, Mirna, come on.
Speed, we will do distance over time.
Distance over time, excellent, perfect. So the speed, it is the distance moved through a unit time or rate of change of distance. Rate, it's like time, the time used to change the distance. The speed we can, its symbol is V, distance D, time T. So we can do this triangle. We put the distance up, and here the speed, and here the time. So velocity or speed is distance over time. What we will do if we want to get the distance? We will do what?
Speed times time.
Speed times time. Excellent. What if we want to get the time?
Distance divided by time, by speed.
By speed, perfect. Distance divided by speed. So if we keep this in our mind, the D here, and here the V, and here the T, we can calculate any question or any example to get the speed or distance or time.
Okay.
Is that easy for you?
Yes, it's easy.
Yes, ma'am, it's easy.
Anyone has any question?
No.
No.
Okay. Okay, I want to ask you a question. The time. We measure time by what? What is the measuring unit?
Seconds.
Hours, seconds, minutes.
Excellent. And the distance?
Meter or kilometers.
Kilometer.
Meter or kilometer. Excellent. Okay. When you answer the questions which will come to you, if the distance in meter, for example, and the time in second, so the speed, the unit of the speed will be meter
per second.
Yes. If the time is minute,
Meter per minute.
meter per minute. Excellent. If the distance is kilometer and the time is hour,
Kilometer per hour.
kilometer per hour. What if the distance kilometer and time is second?
Kilometer per second.
Kilometer per second. So we get the measuring unit of the speed from the distance and from the time. We have to read the question carefully and determine what is the distance, what is the unit of the distance, and what is the unit of the time. And then we will make it like this: meter per second, meter per minute, kilometer per hour, or kilometer per second. Is the measuring units okay?
Yes.
Yes.
Okay. I will write a question for you. If I have a car that moves a distance of 2 meters, in 10 seconds,
Yes.
can you tell me what is the speed of the car?
Yes, ma'am.
Who will answer?
Can I answer?
Can I answer, please?
Okay, come on, Ronza.
Speed equal speed equal distance on time
Distance
divided by time.
divided by
So speed will equal 2
yes,
2 divided on 10
yes, equal
will equal 5 minutes per second.
5 what? 5, 2 divided 10. Do you have a calculator?
Yes. Second, please.
Equal what?
Can I
0.2
0.2. What is the unit here?
meter per second.
Meter per second. Excellent. Because the distance, I told you, it's 2 meters. And the time, 10 seconds. So it's meter per second. Perfect. Thank you so much, Ronza. Excellent. Okay, one more question before we end up our session.
Can I answer, please?
Okay, Sarah, come on. Here we have, for example, tiger running fast. It moves distance of 3 meters. It also moves in 10 seconds. Can you tell me the speed?
Okay, speed equal distance divided time.
Speed equal distance divided time.
Equal 3 divided 10 equal 0.3 meter per second.
Perfect. Excellent, Sora. Excellent. meter per second. Perfect. And if the distance was 3 kilometers, what was here the answer, the unit at the end? It will be what? Sarah?
Kilometer per second. Sorry, my mic.
Yes, excellent. If it was kilometers, so at the end, the speed will be with kilometer per second. Excellent, Sarah, and excellent, all of you. So proud of you. Do you have any question?
No, thank you.
Did
Yes, ma'am.
you enjoy the lesson?
Yes.
Yes, I enjoy.
It's easy, right?
Yeah.
Okay.
Yes.
Bye-bye.
Okay, let's stop here, and I wish to see you again.
Nice to meet you.
Nice to meet you too, Slati. Bye.
Bye.